Hello everyone. Today we'll start a new chapter which is about probability. So probability help us to quantify uncertainty associated with events and that helps to understand how likely events are to happen. So let's begin with the learning goals associated with this lecture. By the end of this lesson, you should be able to assign probabilities to real world event, and then we should be able to connect the concept of probability and relative frequency. We have already talked about relative frequency in our previous chapters. So relative frequency is very closely associated with probability, and in the chapter we'll discuss about that, how they are closely associated. And then we should also be able to apply basic probability rules and use probability concept in our daily decision making, and then finally to be able to link between statistics and probability, because many of the statistical method basically arise from the concept of probability. Let's first start with defining probability. So how do we define probability? As I was saying earlier, like probability is associated with quantifying the uncertainty of an event. So therefore, probability basically help us to measure how likely an event is to happen. And the probability always basically in between 0 and 1. So the maximum probability of happening something could be 1 and the minimum is 0. Therefore, the probability always between 0 and 1. And if the probability is close to 1, that means it is more likely for this event to happen. And if the probability is close to 0, that means it is less likely that this event will happen. Let's start with some basic notation. So to indicate a probability of A, we use this symbol and we call that probability of A. That means the probability of happening of an event A. So if the probability of A equal to 1, that means this is a certain event and that will happen for sure, right? And if the probability of an event, that means in that case probability of A say is equal to 0, that means that event will never occur or never happen. There are several ways to calculate probabilities. So one is through intuition. So this is not probability in the actual sense, but we often use this in our day-to-day life. Suppose like we often use that, the rain of tomorrow is about 70%. So in that case, are we basically calculating the probability? No, we are not. But through our expertise or through our intuition, we are making some assumption about the chance of raining for tomorrow, right? And then we can also use a relative frequency to calculate the probability. And later we'll discuss that with details, like how we can use relative frequency to calculate probability. And then we can also calculate probability for equally likely outcomes, like for an experiment, if all the events has equal chance of happening, then in the situation how we can calculate probability. So now one after one we'll see with example how we can find probability in different situation. Suppose someone says Shala has 90% chance of breaking the all record. So in that case, is he actually calculating the probabilities? No, he is not. Rather, based on his past experience or probably based on the performance of Shyla during the recent time, they are making some assumption about the chance of Shyla breaking the world record, right? So in that case, basically, they are using their intuitions to find probability. We can also use relative frequency to calculate probability. So let's first see how do you basically define relative frequency. So relative frequency is the ratio of frequency over total frequency, right? In that case, F is the frequency of an event and N here is the total frequency. So we can use this relative frequency to calculate probability. So in the next slide with an example, we'll see how we can do that. Suppose you are doing some clinical trial of a vaccine, and assume that this vaccination was applied to 1000 patients and 910 of them showed immunity after taking this vaccination. Then in this situation, how we can calculate probability? So in that situation, we can use relative frequency to calculate the probability. So how we will calculate the relative frequency first? So we will take the frequency, that means here we'll take the number of patients who showed immunity after taking the vaccination, and then we'll divide that by the total frequency, which is total number of patients in that case, and that gives us 0.91, which is our probability in that case. And if we convert that to percentage, then it is 91%. Therefore we can tell the probability of immunity after taking the vaccination is 91%. And therefore we can see like how we can calculate probability using relative frequency. So now we'll see how we can calculate probability for equally likely outcomes. So what do you basically mean by outcomes? For an experiment, if all the events have equal chance of happening, then in that situation we call that a equally likely events, right? So for the equally likely events or equally likely outcomes, how we can calculate probability? So in that case, we take the number of favorable outcomes on the numerator, and for the denominator we take the total number of possible outcomes, and we use that to calculate the probability. And in the next slide we'll see with an example how we can calculate probability in the situation for equally likely outcomes. And now let's see with an example how we can calculate probability for equally likely event. Suppose we are flipping a coin, then if you flip a coin, then head or tail may appear. Therefore in that case we have two events, head or tail, and both of them are equally likely. In that situation, then how we can calculate probability? How we can calculate the probability of head? So what we'll take on the numerator, we'll take the total number of head possible. So if you flip a coin, then how many head is possible? Just one. And then we'll divide that by the total number of possible outcomes. So if you flip a coin, how many possible outcomes there? There are two possible outcomes, right? Head or tail. So we'll divide the favorable outcomes by the total number of outcomes. So in that case, the favorable outcomes are just one, and the total number of outcomes was two, head or tail. Therefore that gives us probability 0.51. That means if you flip a coin, there are 50% chance that head will appear, right? Now let's see what are the different ways we can express probability. So we can use basically fraction, decimal, percentage, ratio, and all of these things basically indicate the same thing. As for example here, the fraction 3/4 is basically same as 0.75, right? And if you convert that to percentage, which is 75%, so all of these basically indicates the same thing, and we can express probability with fraction, decimal, percentage, or ratio. And you are free to use like any of the four which you prefer. Let us now do some practice problem and see how for different situation we can calculate probabilities. So as for example here, say we are doing a survey, and the survey result give us among 500 students, like 375 of the students wear contact glasses. Then how in that situation you will calculate the probability of students wear contact glasses? So in the next slide, we'll see a step by step how we can calculate probability in that situation. So here, like, what is the total number of student? So the total number of student was 500. Therefore, this is our total frequency. And then what is our favorable number of frequency? So in that case, meaning like how many students wear the glasses, and the number of students wear the glasses was 375, right? And then what we'll be doing, we'll be applying the relative frequency to calculate the probability. Now to calculate the relative frequency, what we have to do, we have to divide the frequency, that means the number of students who wear the glasses, by the total number of students. And the number of students who wear glasses was 375, and the total number of students was 500. Therefore in that case our relative frequency, which gives us the probability, is this, right? And if you convert this number, then finally we that give us 0.75, or if you further convert it percentage that gives us 75%. So here you can see, like, by using the relative frequency method, we can calculate the probability, and we can tell like 75% of the student of the college wear contact glasses, right? Now we'll see with an example how we can calculate probability for equally likely events. So here, suppose in a bag we have 12 marbles, and we have to randomly draw a marbles from these 12 marbles. And out of these 12 marbles, we have 5 red marbles, 4 blue marbles, and 3 green marbles. Then if you randomly draw a marble, what is the probability of drawing a red marble? So how we can solve this problem? We'll look into that step by steps. So in that case, what are the total number of balls that we have? The total number of balls that we have were 12 marbles, right? So the total outcomes could be like any of the total marbles. If you randomly pick a marble, then you can pick basically any of the marble out of these 12 marbles, right? And what is the favorable outcomes? What is the favorable number of outcomes? The favorable number of outcomes was 5, because there was 5 red marbles, right? So in that case, our then favorable outcomes is 5. Now if you randomly draw a marble, what is the chance, or what is the probability that you will draw a red marble? So how we can calculate this probability? In that case, then probability of drawing a red marble would be like the favorable outcomes over the total outcomes. So what is the number of favorable outcomes? The number of favorable outcomes was 5, meaning the number of red ball in the bag was 5. Then what is the total number of marbles? The total number of marbles was 12, and that basically gives us the probability, and in that case, which is 0.4167, and if we round this number, which is 41.6%. That means, like, if you randomly draw a ball from the 12 marbles, then the probability that you will pick a red marble is 41.6%. Let's now look into this case. Suppose a photographer, her name is Joanna, and she's claiming that she's almost certain she will photograph well successfully. So in that case, then what basically she's doing, is she calculating the probability using relative frequency or equally likely outcome? No, she's not. She just based on her intuition, saying something like she is very certain that she will photograph the whales. So probably like probability that she will successfully, like, will be able to do the photograph is probably greater than 0.90 or less than like 1, because she is almost certain but she is not 100% sure, right? So in that case, basically what she's claiming is based on just her intuition, right? So let's now see what we basically mean by law of large number. So law of large number basically tell us, as the sample size increases, then the result that we get by relative frequency, then it's become closer to the theoretical probability. As for example, say if you flip a fair coin 10 times, then 7 of the times head might appears. That means 70% of the time head is appearing, right? But ideally, like, this percentage should be like 50%, right? But here we are just flipping the coin only 10 times. Now what will happen, say if you flip the coin 1000 times, then it is very likely that about like 500 times head will appears. That means in that case the probability will be around 50%. And you can see, like, if the number increases, then the relative frequency basically become very close to the theoretical probability, right? And that is basically is known as law of large number. So as the sample size increases, then the relative frequency becomes close to the theoretical probability. So now let's see, how do you define the complement of an event? So the complement of an event, say A, indicates like the A does not occur, and we denote that by the symbol, and we call that A complement, which means the A will not occur. And there is also another important thing that we have to remember, that the probability of A plus the probability of A complement is always 1, meaning the probability that A will happen plus the probability that A will not happen is always 1. And from this equation we also get that, like, probability of A complement, that means probability that A will not happen, equal to 1 minus probability that A will happen. Let's now clarify it further with an example. What do you basically mean by complement? Suppose an event A that indicates a student will pass in the exam, and the probability that the student will pass in the exam is 0.85. Then the complement of A is basically whether the student will fail in the exam, and the probability that the student will fail in the exam is equal to 1 minus 0.85. Here the 0.85 is the chance that the student will pass in the exam, and therefore the probability that the student will fail in the exam is 0.15. And if you notice, like, the sum of these two probability is always 1, and that we also understand that by our experiments, like, if somebody take part in an exam, then he will either pass or fail, and the total probability that he will either pass or fail is 1, right? So let's now discuss about some key probability facts, and we'll start with a statistical experiment. So what do you basically mean by statistical experiment? Any random activity with a definite outcome is known as a statistical experiment. As for example, like rolling a die or drawing a card could be an statistical experiment, right? And then what do you mean by simple event? So one specific outcome of an experiment is known as a simple event. As for example, like outcome 4 after rolling a die or drawing the ace of spades from a deck of card could be a simple event. And what is sample space then? So sample space is the set of all possible simple events. As for example, like if we roll a die, then what are the total possible outcomes? The total possible outcomes is like it could be either 1, 2, 3, 4, 5, or 6, right? Then the set of all of these possible outcomes is basically our sample space. And say if you roll a coin, sorry, if you throw a coin, then what are the total possible outcomes? Head or tail, right? Therefore our sample space in that case would be like head or tail, and so on. So now I think it is clear to all of you, like, what do you mean by a statistical experiment, and what is the difference between simple event and sample space. Let's further look into some more key facts that we have already discussed. So we already know that, the range of the probability will always lie between 0 and 1. And we have also discussed, like, the sum of all the probabilities of all the events related to an experiment is always 1. And we have also discussed about three method of finding the probability: through intuition, through relative frequency, and we have also seen, like, how we can calculate probability for equally likely outcomes. And then we also already know, like, the probability of an event plus the probability of the complement of this event is always 1. That means probability that something will happen plus probability that that will not happen is always 1. I think by that time, it is clear to all of you, like, what do you basically mean by probability and what the probability basically tell us. So if the probability is close to 1, if the probability is close to 1, that means, like, we are very sure that something will happen. As for example, if the probability is 1, that means that things will happen for sure. If the probability is very large, that means it is very likely that this thing will happen. On the other hand, if the probability of something equal to 0, that means it is impossible to happen and it will never happen. And if the probability is very small, that indicates that, the likelihood that event will happen is very low, right? So we've already have good idea about that, I guess, by that time. Let's now clarify on some misconception that we might have. So, say you are flipping a coin and many times tail has appeared. then you might be thinking in the next flip the probability of head will appear increases, but that is not true. The reality is each flip coin is independent, then the chance that head or tail will appear in any of the flip is always 50-50. That is the end of this module, and I believe now you have some good idea about what is probability, and we have also discussed like the probability always in between 0 and 1, and we have also discussed about the three methods of finding probability. Then we have also discussed about what do you mean by complement, and the probability of an event plus probability of the complement of this event is always one. And we you also have like very good idea about the law of large number. So thank you everyone. See you in the next lesson.